So for 11.6, we're skipping 11.5 because it's actually more involved than what we're going to do today and tomorrow. But let's start with 11.6. So 11.6, we're basically putting two events or more together, okay? And we're combining them with the word or. Sometimes not. But these are the two words that we're going to focus on. And as you'll see soon, this one typically means addition. So whenever you see or, that means that we're going to be adding our probabilities together in some way, shape, or form. Okay? Not is pretty self-explanatory. For example, if you have 500 Americans, 270 said that their health was good or excellent. Okay? So 270 had good or excellent health. Well, how many people did not have good or excellent health then? 230, right? Not good or excellent. And since those were the only two options, I hope this makes sense to you, that if you add both probabilities, you get 1. Okay? Are there any questions on why that is? Does that make sense that if you have let's say we have an even more complicated event, if you add up all the probabilities for everything happening, that you're going to get 1, right? Okay. Now, this is actually an important one here. So let's say we have a simple event. The probability of an event happening plus the probability that it does not happen is equal to 1. Okay? And from that little equation, we'll actually utilize this more later. But if you move this over to the other side, now you get the probability of something not happening as just being 1 minus the probability that it does. Okay? Which is a pretty important formula to know. So make sure you remember this. Okay? And so now let's just start working through some of these examples. If you're dealt 1 card from a standard 52 card deck, find the probability that you are not dealt a queen. Okay? There's obviously, and this is not a hard problem, but there's 2 ways that you can do this. If we're doing it the way that we're kind of following the model here, the probability of not getting a queen would be the same as 1 minus the probability of what? Of getting a queen, right. So if I do 1 minus, what is the probability that we get a queen? How many queens are there?
4.
So 4 out of 52. We type that in the calculator or do it by hand. It's not hard. You should get 12 13ths, I think. Now, you could also have gotten this without really doing it this 1 minus business. I mean, if there's 4 queens in the deck, it should be pretty obvious that there's 48 cards in the deck that are not queens. So you could have just gone straight to here to get that. Okay, but it's important that you understand this concept, that you can find the probability of something not happening by just doing 1 minus the probability that it does happen. Okay, because as things get more complicated, this will be much easier than actually finding the probability that it does happen. Okay, 1B, let's do that one. So the probability that we don't get a diamond is going to be the same as what? 1 minus the probability that we do get a diamond. How many diamonds are there in the deck?
Yeah, 13.
So we do 1 minus 13 out of 52. And if you reduce that you should get 3/4. All right. Read example 2 and try that on your own, please. All right, Philip, walk us through. Ryan, walk us through.
So this is not the army. The army has 470,000 people in it. So I get 1 minus 470,000 over 1.370.
1370123. And what did you get?
90 over
90 over 157?
157.
137? So it's just 1 minus probability that we're not in the army. Okay. Nicely done. Any questions? Okay, let's turn the page. Question?
Okay. I was like,
All right. So the last part of these notes, you guys, focus on events, like more than one event at a time. Okay, so there's 2 different ways that more than one event can happen. The first is mutually exclusive. You do need to know this vocabulary. Mutually exclusive just means that it is impossible for events A and B to occur simultaneously. Simultaneously is just a fancy word for at the same time. Okay? So, for example, let's say I'm picking a card, and I'm interested in picking either a 10 or a jack. Would those be considered mutually exclusive? Ask yourself this question. Is it possible to pick a jack and a 10 at the same time? Really? There's one card, one card only. There's no such thing as a 10 and a jack together, right?
I thought you were talking about like if you pick like 2 cards.
No. So if we're picking one card, that's a good clarification to make. If you're picking one card, picking a 10 or a jack, those 2 things cannot happen at the same time. Does that make sense? So that is what we mean by mutually exclusive. On the other hand, what if I said I'm picking a card, what's the probability that it's a spade or an ace? Is it possible to pick an ace and a spade at the same time? Yes, it is. Right? Does that make sense, you guys? Let's look at these examples, okay? But here's what we're going to do. When we have probabilities with the word or, we're going to add the 2 probabilities together. Okay, it's pretty simple to do. Now, if the events are not mutually exclusive, and I'll kind of show you how this works with the Venn diagram. It's the same formula, but you have to subtract out the probability that event A and B happen at the same time. Okay? So I'm going to actually just do one example of each. So let's say we pick one card. What's the probability that we select a king or a queen? Well, so this is just going to be the probability that we select a king plus the probability that we select a queen. And since it's impossible to select a king and a queen at the same time, if we're just doing one card, then this is all I need to do. Okay? So how many kings are in the deck?
4.
How many queens are there?
4.
So final answer is 8 out of 52, which reduces to 2 out of 13. Okay? Does that make sense?
Yes.
Okay. Now let's jump down to an example of not mutually exclusive events. Okay? So here, actually for this one, I'm going to draw a little Venn diagram. Have you guys seen these before?
Yeah.
Let's say this represents math. This represents psychology. Okay? In a group of 50 students, 23 take math, 11 take psych, and 7 take both math and psych. Where does the 7 go? And now 23 take math. So that means I've already got 7 in there. So how many are out here? And 11 take psych. 7 are already accounted for. So that's going to be 4 in the other part. Does that make sense?
Oh, I thought you were doing like the actual problem. Why the balloons?
So, if we want to find the probability that the student takes math or psych, and this is how I always go about doing this. As soon as I see the word or, I split it up and do addition. So it's the probability that we're in a math class plus the probability that we're in a psych class. And is it possible to be in both a math and a psych class? Yes. So we have to subtract the probability that we are in a math and a psych class. Okay? Now look, this is not the only way to do this, but I'm just illustrating how the formula works. If I figure out what the probability is that we're in a math class, purely a math class, well, 23 out of 50 are in math, right? Plus, how many are in psych? 11 are in psych. However, and you can see in this circle that we've counted 7 people twice. Does that make sense? That's what this represents out here. You subtract out those 7 that were actually in both because we don't want to count them twice, and now that'll give us our answer. What do we get? 27 out of 50. Good. Any questions?
No, sir.